So I'd like to begin by acknowledging the traditional owners of the land on which we meet today. I'd like to pay my respects to elders past, present and emerging. I'm hosting this event from Irukandji territory. So welcome to our third ASP Focus Series seminar. And in a minute, we'll hear from Associate Professor Justin Boddy, and he's going to talk to us about how to run a carbon neutral conference. Okay, so Assistant Professor Justin Boddy is the lab head at Walter and Eliza Hall Institute of Medical Research. He obtained his PhD in microbiology from Griffith University at the Institute for Glycomics. His laboratory studies malaria and in particular how parasites are transmitted to mosquitoes and how they infect the liver following injection by mosquito bites. The laboratory uses Plasmodium falciparum insectary to perform this research and aims to identify new solutions to fight malaria. Justin is the co-chair of WEHI's Environmental Management and Sustainability Committee, and that's responsible for assuring the Institute transitions to net zero carbon emissions and works sustainably. Justin holds an NHMRC Investigator Grant Fellowship and last year was awarded the Kellaway Excellence Award for Sustainability for his work as co-chair of the International Conference Molecular Approaches to Malaria and attaining carbon neutral certification of this conference by the Australian Government. So welcome, Justin. We're all really looking forward to hearing you talk about MAM and how you achieved the carbon neutral certification for this conference. This seminar is being recorded, so take it away, Justin.
Thanks, Lisa. Thanks, Thori, and thanks everybody who's involved with this forum. Really pleased to be a part of it. Thank you for the invitation. And I'm really happy to talk to you, provide you some of the information behind what we achieved with respect to MAM last year. But I'm going to sort of take you through a couple of things to lead up to that. My talk today is going to basically talk quickly about climate change, and I think we've all heard about the IPCC recently because they released a sixth assessment report in the middle of August, and it got a fair bit of publicity. So I'll just bring that into the mix at the beginning, and then talk about scientific conferences as you as scientists or people interested in conferencing would understand. There's the good, there's a little bit of bad, not too much, and then the ugly. So that will take us and lead us nicely in, I think, into carbon neutral conferences and what are they, and what is carbon offsetting? How does carbon offsetting work? Is it a good thing to do or not? And then I'll take you through the steps associated with carbon neutral certification. And I just want to say it's really straightforward. And if I can be of any help in the future for you organising a conference, whether it's related to malaria or not, it's really what I want to do and be a part of. So I'm happy to help you however I can. I'll conclude by giving you an overview about some numbers with respect to MAM from last year. So of course, climate change is a really big issue at the moment. There's this wave of COVID-19 pandemic really drilling us down at the moment for lots of us, keeping us in lockdown. But I think there's an even bigger threat behind this pandemic wave, and that is the long-lasting effects of climate change. The climate change is occurring as a result of emissions of greenhouse gases, and carbon dioxide is one of those, but there's many different types of gases that are emitted, and CO2 seems to get the spotlight, but there are others as well that need to be factored into and taken into consideration. But of course, as we started to burn fossil fuels and produce our own energy, allow us to be transporting ourselves and our goods and also our food, we started burning more and more fossil fuels and emitting more carbon dioxide and other greenhouse gases. It's quite complex. So human activity is responsible for some of these emissions. And I just want to preface at this point and say that I'm trying really hard to make sure in this seminar that it's not a political seminar. I'm not a climate scientist. I'm a microbiologist. So anything that I say with respect to climate change, I aim to give you references for those. And I'll try my absolute best not to be political about this because I know it can be very polarizing. I just want to sort of take you through what is accepted knowledge. As of today, of course, there's all of history's emissions in the air, and we currently emit about 30 billion tonnes of carbon dioxide into the atmosphere every year, representing about 85%. So by far the majority of the CO2 that goes up into the atmosphere is from human-related activity. And for those scientists in the audience who know about using CO2, maybe for your cell cultures or something, you'd understand that regulates pH. And CO2 will affect the oceans as it's more of it's being emitted into the atmosphere. It also will end up in the oceans. So that will cause acidification of the oceans. So there was this eureka moment really for me around MAM, organising MAM in the lead up to it was in February of last year that the conference took place and was co-chaired by Tanya de Koning-Ward and Freya Folks and myself. And these bushfires, really devastating bushfires that I'm sure you all remember that occurred around Australia, all over Australia. So before we were wearing masks to protect us from COVID-19, people were wearing masks because of the poor air quality as a result of massive bushfires around Australia. And I can remember as we were heading into New Year of 2020, end of 2019 and into 2020, this devastating bushfire situation that was happening in Australia, it seemed to be unprecedented. And wanting to see what we could do and talk to Tanya and to Freya about this, and decided that we could take an opportunity within a very short period of time between then and the conference starting to make a statement about climate change and try to make the conference carbon neutral. So these fires did precipitate some of that concern, and I'm sure you all were concerned at that same time as well. I'm doing my best to cite the people who've produced these photos that have been used from the internet. So you can see here from my fire watch that there's indications of fires, spot fires all around Australia during the summer of 2019. It began, I believe, in September of 2019 in different parts of Australia, and then spread throughout that summer and into 2020. And there were pretty devastating images if you looked around Sydney and also here in Melbourne. This is around the Australian Open time, where I think that we had the worst air quality in Melbourne in the world at that time. And I believe that's also true when it occurred in Sydney. These events cause problems to human health, unquestionably, but they're also causing problems to the environment because they're releasing so much CO2 and other greenhouse gases that have been stored in wood as a result of plants and trees using photosynthesis and using carbon to produce energy. So there's these images that were really quite harrowing of Malakuta on the far east coast of Victoria, where people had to evacuate and go to the beaches and sit in boats overnight and be kept safe in that way. So no doubt you'll remember how devastating they were. The realization that this was of a global kind of scale is from these images taken from NASA and from the Bureau of Meteorology. They show quite clearly that there's smoke plumes coming from eastern parts of Victoria and New South Wales that stretch over 5,000 kilometres across New Zealand. And in fact, the smoke plumes ended up reaching South Africa and then encompassing the entire circumference of the Earth. So huge amounts of deforestation, forest loss, animal loss. Humans died as a result of it, but also their health was affected because of the changing climate. And you can see in these two images here the degree of smoke that is stretching across more than the east to west side of the United States, for example. And the effect that it had in New Zealand, for example, is shown here. New Zealand had no fires at that time. And this is near Christchurch on a normal day. And this is during this bushfire outbreak in Australia. So I think it made the people of New Zealand really conscious of just how bad it was for themselves, of course, but also for Australia as well. So climate change, yes, we're seeing more bushfires around the world. So in the United States, in Europe, we're also seeing record temperatures and long heat waves. So here's some data from Antarctica, where we're seeing loss of ice sheets, and we're seeing it was on the 6th of February in 2020 that the highest recorded temperature in Antarctica occurred and was measured. And each year before that was an increasing record. So it's culminated last year in the highest measured temperature in Antarctica, and there's a lot of loss of ice and rising seawaters as a result. And of course, with climate change, we observe changes to our weather. So more extreme weather events. 2020 completed a record year for the production of storms and hurricanes, reaching here from the western tip of North Africa all the way across to the east of the United States. And there's 6 hurricanes shown here. These are typically, I guess, considered to be reasonably rare events, but they're becoming now the norm. So there's going to be more slides, I think, around climate change as we move through this talk, but I wanted to talk about how climate change is measured and how it's assessed. I'm certainly not involved in the absolute research at that forefront, but there are many thousands of people that do that research and publish it every year. So there's lots of empirical data that is produced. And so the United Nations established the Intergovernmental Panel for Climate Change, or IPCC. And they were established over 30 years ago to inform policymakers. They don't conduct their own research. What they do is undertake systematic review of all published relevant literature, and then release themselves reports as a result of their research or their work. And so in mid-August, there was a lot of press around the release of this 6th assessment report, which is actually only the first of 3 parts. It was called the Physical Science Basis for Climate Change. And there's 2 more parts that will be released next year. And you can see them there, they're indicated. So this 6th assessment report was certainly interesting to me. It made me go in and look a bit deeper at what it was that they wanted to say. And actually they had press conferences and press releases where they shared some data and some slides. And so what I've decided to do is, rather than reinvent the wheel, is to share with you some of the slides that they presented as a result of their report. And those slides are available through these channels that I've indicated at the bottom. And something that's quite striking that was linked to this report is that in the 30 years since the first IPCC report in 1991, humans have emitted 41% of all CO2 that they've emitted since 1750. So we're certainly doing it now as we expand and move forward into our sort of rapidly expanding technology and style of living. So what does the latest IPCC report say? So this is the front cover of the report, just to show you. Again, it's freely available on that website for you to have a look for yourself. And these slides were released by them. So I'll just take you through a few of them because I think they're really interesting. So this report looked at over 14,000 scientific publications around climate change. 234 authors from over 65 countries. A bit under a third of the authors were women. Definitely could do more there, but nonetheless, almost a third. And this was went through review, so there were over 78,000 review comments. So the IPCC concluded that recent changes in climate are very widespread. They're rapid and they're intensifying, and that they are unprecedented in thousands of years. And really that's exemplified by these data shown here. So looking over about 2,000 years of measurements of global surface temperature relative, I guess, in this graph to 1850. And what you can see is these seasonal increases and decreases that occur naturally. And then since about, well, the 1920s onwards to 1950s, this enormous spike begins to appear in the global temperature. So really, you can see in this early part of the graph, these sort of high and low natural variation from warm and cool times of the year. And then if we look now in 2020, in the past decade, we've actually crossed this 1 degree barrier for the first time. So the Earth's temperature on average has increased. Yes, we'll still be experiencing winters and we'll be experiencing summers, but the average temperature has increased by 1 degree. And that can really be traced back over the past 4 or 5 decades and overlays with the industrial manufacturing and transportation processes as the human population has grown and expanded and built up new technology. So the measurements in the report summarize that the concentration of carbon dioxide and other greenhouse gases in the atmosphere are highest that they've been in at least 2 million years. That the sea level is rising at its fastest rate in at least 3,000 years. That Arctic sea ice is at its lowest level in at least 1,000 years, and that glaciers are retreating at an unprecedented rate seen in the last 2,000 years. Obviously, that then has an impact that this is an ecosystem, so there'll be knock-on effects. So as you alter the climate, you experience more extreme heat when it's hot, and you'll experience them more frequently, and they can be more intense. So you'll hear, no doubt you've heard record temperatures across different parts of the world as they experience their summers, and we hear about heat waves, and of course people dying as a result of that. But that then has a knock-on effect on the water cycle, and so you'll end up having drought, which will have quite severe consequences. And then as a result of drought, you'll end up having very heavy precipitation of rain, and that can be quite frequent and an intense rainfall. So you'll have flash flooding and landslides, and the loss of housing, loss of life, loss of a huge economic cost as well as a result of insurance claims, etc. Of course, these knock on to fire and fire weather, because drought is a very clear preceding event leading up to bushfires, and there's more dry fuel to be burned. So you'll have more frequent fire weather that actually goes for longer in period of time. So the fire season will be extended and become more frequent. And the oceans warm, there's warming, acidification as they lose oxygen and take up more carbon dioxide. So the IPCC report states that unless there's immediate, rapid and large-scale reductions in greenhouse gas emissions, then limiting warming to 1.5 degrees will be beyond reach. So this number of 1.5 degrees is an important number. It comes, I think, from an agreement that was made, what's called the Paris Agreement, where the setting was to establish 2 degrees as the limit, the absolute limit, but preferably to 1.5 degrees. And there will be another congregation in November of this year to reevaluate the Paris Agreement. So I think the challenge for us is to be considering whether we can achieve keeping global warming to within 1.5 degrees, or whether the situation is going to be worse than that, if it's going to hover above 2 degrees or ultimately get to 3 or 4 or even 5 degrees. And all that is within this century. So here we are at about 2020. We've now crossed this 1 degree barrier, and we're trying to, I guess, kickstart the planet into a cleaner set of living situations so that we can try to keep warming below 1.5 degrees if possible. And as you can see for the modelling, for that to happen, we need to have either very low or low CO2 emissions. As we move forward through the next, I guess, decade, you'll see that the trajectories that we set now and through the next 10 years will really help dictate where we end up on these trajectories. And so all of the decisions I think we're trying to make now around achieving, for example, you may have heard of net zero emissions by 2050, for example, is to try to achieve reductions of 2 degrees or less. And I think it's really just easy to summarize what the IPCC have said in that it's indisputable that human activities are causing climate change. That's not me making this conclusion, that's their independent conclusion. That we're making extreme climate events, and that we are including, this includes heat waves, heavy rainfall and droughts, and that they are more frequent and severe. So climate change is already affecting every region on Earth in lots of ways, and the changes we experience will continue to increase as the Earth warms. And that will affect water. So obviously we have water in all of its forms. We would often think of the ocean or in the sky, but it's also, of course, stored in land and it's frozen. And so with warmer temperature, you'll have more water in the atmosphere. And that water cycle then will shift. So more water in the atmosphere means you'll have faster evaporation, which will then make faster rainfall, heavier rainfall, and therefore intensifying dry and wet seasons as well as droughts. So that will result in more of the sorts of things we are already seeing, I think, in the news with respect to high levels of rainfall, flash flooding, storms associated with flash flooding. If you look at the United States recently with Hurricane Ida, there's just a lot of this happening, and that's going to be, rather than rare events, record-breaking events. They seem to be the new norm. To limit global warming, strong, rapid and sustained reductions in greenhouse gases are absolutely necessary. And of course, this wouldn't just reduce the consequences of climate change, but it would improve air quality for millions of people who live in areas where air quality is really bad. If you think back to whether or not you were around the bushfires and inhaling the smoke at that time, we would wake up in the morning, perhaps it was really, really smoky, and then the wind would kick in and it would take it away and we'd have fresh air again. But there are people who live around the world in really poor air quality situations. So the climate we experience in the future is obviously dependent on how we act now and the decisions that we make now. Of course, there are a few hugely emitting companies that will need to change their behaviours, but I think each of us needs to feel like we're doing something, and each of us can be doing something proactive, because every tonne of CO2 saved is an absolute fantastic achievement and goal that we should be trying to achieve regularly. So takes us, I guess, a segue through then to conferences. Conferences are a fantastic part of our life as scientists. They allow us to go to new places in the world, to see friends and colleagues and meet new people. Very exciting. You get to hear about the latest research in your area, expand your knowledge and change your thinking. I don't know about you, but I know when I come back from conferences, sometimes my team don't want to talk to me much because I've got lots of new ideas and we want to do some a lot of new different things. And that's what conferences do. They help you get out of your current work zone and expand the way you think. It's also fantastic to network and meet with other people in your area, share ideas and come up with brainstorming ideas, communicate your results, and probably work on improving your presentation style and skill sets, and also bolster your CV as well. So there's lots of positives. I think it's important to acknowledge that going to conferences is a really important way for people to meet you and to know what you're doing. That's really important. And it helps us to establish new collaborations, but also to sustain current collaborations and keep them going. I tried to think of some bads, but there aren't too many bads of conferences. I guess they are, in some cases, costly and can be a long way away. I think the major negative is that they do exclude a lot of scientists for a variety of different reasons. Geographically, they can be expensive to go to, and that can preclude a lot of people from going to conferences. And I think that online conferencing has a great opportunity to help fulfill a gap there with respect to more inclusion and more diversity at conferences. Jet lag, yeah. Time away from family and work. I mean, that can be bad, it can be good. It just depends how you're feeling and which way you want to look at it. Yeah, I mean, obviously conferences, like most human activity, if you go and put the your washing machine on, or turn on some lights, or even when you put things in the rubbish, they'll go into a tip and produce emissions. All of our activities have emissions associated with them. So conferences do, and it's largely through ground and air transportation. And I'll talk more about that as we progress through the talk today. But of course, the production of electricity, how is it being produced? Where's the food come from? What sort of food is it? And how is it being transported? What are the wastes? Can you minimize wastes? There's often a lot of waste from conferences. So all of these things link back to greenhouse gas emissions. So they're obviously a core part of our life as a scientist, but they can have some negative effects on the environment. So I guess the idea is to try and strike a balance that's right for you. And what's right for you will be different to me or different to other people. And it's really, I guess, about stopping and thinking about what's the right balance. And maybe now's a good time to do that because we're all experiencing pandemic at the moment. So our general activities have been slowed. I'd love to even to be coming to Cairns for the next ASP conference, but unfortunately that will have to wait. And it gives us time to think about what's the right mix of attending online conferences. Again, it will allow people who can't ordinarily be there to be there. And it'll allow you more time to do other things as well as going to face-to-face meetings, which I think we'll all probably agree you can't replace. They're invaluable experiences that we have with each other. But I think integrating online conferences in the long term is one solution. And then I guess asking yourself how many in-person conferences is right for you. Is going to 5 international conferences. I know some people who are going to 10 or more conferences a year, traveling a lot. Is that absolutely necessary? Maybe it is, and maybe it isn't. If you do go to in-person conferences, I think considering offsetting the carbon from the flights is a really important thing that could be done. If you're interested in trying to be better about your carbon footprint, excuse me. And if you see carbon neutral conferences, I think it would be great to attend them or at least support them. So what does carbon neutral really mean? I think it can be a bit confusing. So it's really actually very simple. There are obviously emissions associated with all of our activities that we do. The question is, can we reduce those emissions in some way? It won't be to completion, but can we reduce them? So an arbitrary example here is, if we're going to arrange food, could we arrange that it comes locally and doesn't involve lots of transportation? In that way, it will reduce some of the emissions associated with consuming that food. So it's just one example of myriad ways that you can reduce emissions. So that's the very first step. But then, of course, there'll be some remaining emissions that are unavoidable. You can't avoid doing them because we don't have the societal technology that allows us to have zero emissions. So if we're having an international conference, then I think stepping on an aeroplane is a vital part of getting there, unless you've got months and months up your sleeve. But there would still be emissions associated with other forms of technology. So until we move to clean, very clean transportation, there's going to be remaining emissions. So the question is, well, then what do you do to offset that or neutralize the emissions that you have to emit to have your event take place, for example? And what that involves is offsetting. And you've probably heard of carbon offsetting before. It just means that if you can identify areas where carbon dioxide and other greenhouse gases are almost certainly likely to be emitted in the future, can you guarantee that you could stop that from happening? And if you could you measure how much you would stop and therefore basically bring your position to net zero, which is that you would emit what you need to emit, and you would then go towards stopping the equivalent amount of emissions in the future, tomorrow, maybe in the next 5 years, 10 years, depending on what that carbon offset project is. And there's lots of carbon offsetting projects. I'm going to talk to you about what some of those are. So carbon offsetting is not a silver bullet. It's not the perfect answer because it doesn't stop all emissions. Emissions will still happen. But what it does is it helps you to identify where emissions probably would have happened anyway, and to then go in and stop those from happening. So rather than having double the amount, you have a net one amount of emissions going rather than two. The other way that you can do it is to use the carbon cycle, where reforestation and plants use and store carbon. And so there's been a lot of carbon offsetting programs around reforestation and planting of trees, but there are lots of other ways to do it as well. So offsetting effectively, I think all of our activities result in emissions in one way or another. And some of us will have bigger footprints than others, particularly large corporations associated with energy production. They are the largest emitters. And so at the moment, it's voluntary, but I think we're, as a world, heading to a direction where we need to look at our behaviours and find ways to offset our emissions. So to stop the rate with which CO2 is going up as we transition to newer types of technologies where our society ends up being a clean society. So I think as scientists, we are the people who observe the changes. The scientists will observe the consequences of climate change. It'll be the engineers and ultimately the technology that gets us to a clean society. And in the meantime, we have to use the current system we have to achieve a cleaner set of ways of living. And so I think offsetting is an important part of that step at the moment, because it will cancel out some emissions. It will reduce some of the emissions that go up. So how can you do that? So for example, if we know that a coal-fired power plant is going to produce X amount of electricity per day, and we know that an equivalent could be produced using renewable energy, either solar or wind, then we could invest money to allow that energy to be produced in that way, as long as it's regulated and that CO2 that would have been produced via a coal or thermal power plant is actually not coming up into the atmosphere. So you can do that through renewables. You can do it through, as I've mentioned, reforestation and revegetation, because plants consume carbon and they store it. But that becomes volatile because of things like bushfires, and then you'll have mass release of carbon. So carbon sinks or carbon storage for can you guarantee it's going to be stored for a long time? I think is a really important question. So landfill, every piece of rubbish you put in the bin will end up, that ends up going to landfill, will eventually decompose and produce methane and other greenhouse gases. So that is an effective way to reduce emissions. Same with cooking. If people use wood stoves and produce more waste than, for example, maybe renewably powered electric cooking. So that's an option. I think we've already covered fire management, given how important trees are to storage of carbon. The way that trees and forests are managed and fire management is really critical. So there's a lot of work in this space. And then the production of food. It's also really important. So to give you a breakdown of the types of carbon offsetting programs that people are investing in as of 2019, renewable energy became the #1 source of carbon offsetting. So this is in megatons of CO2 emitted that is being offset. So commonly, if you were going to go and fly overseas 10 years ago, you may well have offset your flights, and some people would have gone and planted trees. That is a fantastic activity to do, but there are now a lot of other activities that are as good, including purchasing the production of renewable energy. So waste disposal, household devices, the way things are transported, there's lots of different ways. It's not just about planting trees. And it's not just about, I guess, offsetting carbon. Greenhouse gases are a complex mixture. So if you can stop emissions or reduce emissions, it won't just be CO2, it'll be a mixture of gases that you can help prevent from being emitted. But the other, I guess, important things that we need to speak about are that offset projects will benefit other aspects of life. So for example, if you talk about fire management, there are Indigenous Australians, Aboriginal people who understand over many generations how to manage their area of living and have really outstanding knowledge around fire management. So using carbon offsetting programs to provide, for example, Indigenous people with the opportunity to do that work would not just have a carbon offset benefit, but it would also benefit their cultural experience. It would give that person a job, and it would give them social benefits as well. So there's a whole picture here, I guess, that I'm trying to draw there for you. So how do you go about then getting certification about a carbon neutral event, or do you even want to do that? That's I guess a key question, and that's where we started as well for MAM. Do we want to do this, and if we do, how do we do it? Do we just offset the invited speakers' flights, or do we just do one of the sessions? There's just a lot of different ways that we could go about it, and the good news after a bit of research was that it's all predetermined and been written out for us by the Australian government. And it's really quite straightforward to follow their rules. We didn't have to reinvent the wheel, we just had to follow the standard that was written by the Australian government. So what this slide here is really, I guess, trying to depict is that if you've got an organisation like your university or your institute, a business where you work, or if you work for a company that produces products and they want to have that product certified to be carbon neutral, or in the case of conferences, if you want that event to be carbon neutral, what you do is you apply to the Australian government's Department of Industry, Science, Energy and Resources, and they will provide a set of criteria that you can follow. But the way they do that is they get you to work with their subsidiary department, which is called Climate Active. And you may have already seen some of the slides had this logo from Climate Active. So Climate Active are a part of the department, and they work with you to achieve the certification that you want, either for, maybe it's for building a new building and you want that building to be a carbon neutral building, then they'll work with you to achieve that. So in the context of conferences, what we needed to do was to download the document from the link that I've put there at the bottom, which was the carbon neutral standard. That outlines all of the criteria that you have to meet. There's not that many, and it's really quite straightforward. So for events, there's this document. The link is there for you. This is being recorded if you need to come back to this later. Or you just Google Climate Active and carbon neutral events, and you'll find your way to the standard pretty easily. It was very exciting to find this document because it tells us the things we need to do. Basically, for events, we needed to follow the following 4 steps here. Calculate the greenhouse gas emissions generated by our activity. So we just kind of had to think about it. If we're going to fly people from all over the world to Lorne, or into Melbourne to go to Lorne, how much greenhouse gas would be emitted as a result of that? And that can be a bit hard to calculate, but on the next slide, I've got some answers there for you. You also do need to try and reduce your emissions as much as possible. So like I've said, for example, could you use renewable electricity, or can you source food or other supplies locally rather than having someone from a lot further away? So whatever you can to reduce your emissions is necessary. You need to state what you'll do to do that. So for example, I think we had air conditioning in the outdoor area in the marquee just for one of the days. And I think we didn't have air conditioning for the remainder of those days as a way to reduce our emissions as well. Surprising how much energy they use. And then for those unavoidable emissions, we needed to pay upfront for offsetting. So we had to pay in advance of the conference. So we had to do a calculation of what we thought was going to be our residual emissions and then go and offset them. And then once we'd cancelled out our emissions of the future, we would then basically had reached this carbon neutral state that I've mentioned. So it's really 4 steps. The first one is to establish your emissions boundary. So that kind of means how far out do you want to kind of cover yourself in terms of the emissions that are being produced? So if it's a national conference, it'll be probably people getting taxis wherever they are to their airport and then coming to the location. For us, that was a bit more complicated because we had about 450 people, half of which came from, I think, 24 countries. And so we had to basically get everybody's individual itinerary and provide that to some people who helped us calculate the offsets. And for people who have to have multiple flights, that would dramatically increase their emissions because as aeroplanes, I was going to say launch, as aeroplanes take off, they consume the most and emit the most fuel. So the more flights you take to get to your destination, then of course, the more you're going to emit. So we had to work out where is our boundary. So that would be if someone was in Africa, they're going to get a taxi to a local airport, then they're going to fly to a bigger airport, and then they're going to come into maybe 1 or 2 other stops to come in. And then we needed to work all the way through the emissions internal to the conference. So we had to, I guess, collect data on those identified emission sources, which was really quite straightforward when we brought in consultants to help for a minimal fee. And then I guess what we do is then the 2-step reporting. We have a pre-event report that we have to submit, which involves this carbon accounting of what you do before the conference. And then afterwards, just to double check that our guesses or estimates before were accurate. And also there'd be additional things that we didn't plan might happen that took place. So you do have to do this post-event accounting as well. So I hope that I'm not confusing you because it is really quite straightforward. The first thing is a pre-event report, and I'm going to take you through our post-event report in a few slides. That gets submitted to Climate Active. They will then certify your event, and then you're free to use the Climate Active logo only once the pre-event report has been approved. And I'll show you what that looks like too, because we're very proud that we got that. Now, it's really important, I guess, to mention that there's assistance available to do these things. So there are registered consultants, and there's a list of those consultants on the Climate Active website, for which I've provided links to you. So you don't even have to go and find them. They're there. They're already listed. And I'll tell you who we used at the end, and they have just been fantastic. And I want to continue to work with them as we work through the challenges ahead at WeHi. We then needed to collect data to prepare our inventory. We had to undertake a technical assessment. That report that we submitted was assessed both by our consultant, which gets audited, and then by the department. And then we applied. So there are fees associated with that, but it's really quite straightforward. I think the hardest part is to just break down where the emissions are. So as I've said to you, if someone's getting a taxi in Africa on their way to your conference, that's not really part of the immediate footprint of the conference, but it still is obviously an emission associated with your conference, and that's called Scope 3. Scope 1 emissions include all of the direct greenhouse gas emissions from sources that are within the event's emissions boundary. So fuel registration, on-site electricity generation, all, for example, at the Mantra Lawn where we had the conference. Scope 2 emissions include all of the electricity for the heating, cooling, and energy used both within but also outside of the boundary of the event, but that were used for the event. And then Scope 3 are all those indirect emissions that occur as a result of the fact that the conference is taking place, but they're not necessarily generated from things that the conference provider owns or that the organisers are responsible for, but they're still occurring as a result of the event taking place. So it's actually quite a boundary if you think about it. And if we had to do it ourselves, it would be quite daunting, but the consultants help a lot and make very fast, light work of this. And they themselves get audited just like a tax accountant gets audited. And you can kind of think of it like doing your taxes, I think, with carbon offsetting. It can be for conferences a one-off, but if it was for your institution or university, it could be an annual thing that you do. So I'd like to now just move, I think, to MAM. I think we're doing well for time here. I don't have that many more slides. But just to show you that we were then, once we did the pre-event report, able to put out a statement. So we emailed, we got on social media, and we put on our website that the conference was now certified carbon neutral. I'll just read you this because it sort of explains the way we chose to do the carbon offsetting. So we did this through the Department of Industry, Energy, Science and Resources, and we reduced our carbon footprint where possible, and then chose to offset all of the CO2 emissions produced by the return, ground and air travel. And then for all of the food, drinks and electricity consumed by all 451 delegates, it ended up being 454 delegates, but we were pretty close. And the way we chose to do that was to offset using 3 different programs. The first was the Aboriginal Carbon Foundation in Australia, and that was to support Aboriginal, Indigenous, social and cultural core benefits here in Australia. That's where the conference is occurring. We invested in India Solar to displace electricity generated by thermal power stations in India that would feed the grid. So we used renewable solar, in that case, solar credits. And the third carbon offsetting program we used was a project for sustainable forest management and biodiversity monitoring in the Brazilian Amazon in a state called Amapa. And these 3 initiatives were selected on purpose with consultation with Tanya and Freya and myself, because we wanted to acknowledge where the conference was occurring in Australia, but also that malaria is endemic in India and in Brazil, including in Amapa. So you can offset in different countries because we're all one ecosystem. So you can, it's more expensive to offset in 1 ton of CO2 in one country versus another. So you can split it however you like, as long as you're using the government certified offsetting programs. So this is just a very quick run through, I think, of the report that we put at the end. This is considered a small event, 450 people. Up to 5,000 people is a small event. So that was what we applied for. We gave them a quick spiel about what MAM is intended for, how many people are coming, and how we chose to reduce our emissions voluntarily. And then the fact that flights were identified as the primary emission source because it was an international conference and we couldn't get them here any other way. So we then went about offsetting. And here's then a summary of our post-event report. It looked very similar to our pre-event report, which was a credit to our associates that helped us put this together. And if you just look through the right-hand column at the tons of CO2 emitted, you can see a clear breakdown for what was measured. And some of these data were measured well, in fact, all of them were measured, but using algorithms to calculate. So we would tell them what our menu was, how many people were eating, and they would calculate the food, how much CO2 was produced for food production. And surprise, surprise or not, international flights were by far the huge majority of emissions as a result of holding this conference. And so I hope that speaks loudly to you about the messages I was sending to you before about striking the right balance. We're a long way away in Australia, so those emissions are a lot higher for us to travel or for people to come to us here. We then needed to report how we did the offsets. And so I've listed each of the 3 different projects that I've already mentioned to you. We said how many tons of CO2 we offset from each and what the total amount of CO2 that we offset. So using these 3 programs that are government certified, and audited independently, we were certified carbon neutral because we had guaranteed offset 1,417 tonnes of CO2. And that all up cost us a little under $20,000, but there's fees associated with applying to Climate Active. There's fees associated with the support that we had from the consultants, just a couple of $1,000s. All up, it ended up costing about $40 per attendee, maybe a little bit more. And we chose to cover that from the running budget that we had. So MAM 2020 basically did not run a profit like other previous conferences had. We chose to invest that profit back into making the conference carbon neutral, about $40 a person. For something like that scale, it would be different for different conferences and depending where people are coming from. But I think $40 a person, maybe it's a bit expensive, but for the sake of needing to change our activities, I thought that was a fantastic outcome. Finally, in this report, they told us, we explained what our offset projects were and the benefits of them. And then we were then given permission, I think is the right word, to use this logo here for these particular events here, including presentations like I'm giving you right now and on the website. So this MAM website is still available if you want to see any further information. So last slide to just acknowledge everything I've told you, that everything we're doing today will of course influence the future, and conferences are a part of our life in science. So maybe new technologies will allow us to change the way we hold conferences and the frequency with which we have them. But I think changing from what we did pre-COVID may not be easy. And in fact, maybe pandemic helps us in some way get around that mental barrier. But I think we're probably all experiencing the mourning the loss of face-to-face conferences at the international level for sure. Carbon neutral conferencing is very straightforward to arrange. It takes several weeks to months, but it's really quite straightforward, especially if you get support. And I think you need to just work out the budget for it. And that's probably the key issue. How do you fund it? I think we need to strike the right balance of in-person and online meetings as we move forward. And if you see carbon neutral conferences, maybe think about attending them. If you're organizing a conference, I would urge you to consider getting certification for your conference. And if I can help at all, it doesn't have to be malaria related. It doesn't even have to necessarily be science related. I'd be really happy to support you however I can. A big shout out to the co-chairs, Tanya and Freya, people at WeHi, particularly Shayla Nile, who was in charge of the legal aspects of getting this conference carbon neutrally certified. And she's also the co-chair of the Environmental Management and Sustainability Committee that we're leading together at WeHi. And thanks to Pangal and Associates, who are the consultants that supported us. Ian was particularly helpful. Yeah, I think I'll thank Tanya, Freya, Brendan, Leishman, who are our conference organizer. And with that, I will stop talking and welcome any questions.